So students, question number 20. So actually the electric field of uniform plane wave traveling along the z direction is given by, so here electric field of incident wave, I means incident actually, is equal to Ax plus J into Ay cap E naught E power j k z. Okay. This wave is incident upon the receiving antenna placed at the origin, whose radiated electric field towards the incident wave is given by the following equation. So this is one thing. This is actually for okay. So I want to write something here. That's why. Now this is electric field of the antenna is Ax plus 2Ay, then EI 1 by R e power minus j k r. Now the polarization of the incident wave, that means this one, I means incident, student, and the polarization of the antenna, A means antenna actually, A means antenna. Polarization you have to tell, and the losses due to the polarization mismatch are respectively. Okay, these things you have to find. Now here this incident wave has x component and y component. Here magnitude e power j0. You know that already we have done this in uniform plane wave. Now this one has 1 e power j 90. It wave is traveling in minus z direction. Wave is traveling in minus z direction. So we know that for wave traveling in plus z direction, comma second component, that is y component, second component leads first component, then LCP we have studied, but here wave is traveling in minus z direction, no? So in given question, wave is traveling in minus z direction. So polarization is RCP, student. Actually LCP means I have shown you in the derivation, it goes like this. LCP means for wave traveling in this one LCP, it goes like this. So here wave traveling in RCP means here wave traveling Z is out of the board, but wave is traveling into the board. Cross means into the board. Then actually student, axis was like this. Here I have taken this as electric field x component, I have taken this as electric field y component, I have taken. Z is out of the board, wave traveling direction. But now also this Z is out of the board only, but for this one you have to take right hand and put the right hand thumb into the board now. So that is giving RCP means right hand will be matching now. So right hand will be matching. Actually students, RCP means right hand matches. So out of the board is wave propagation direction. Now here wave is traveling in minus z direction. That means minus z direction means into the board. So you have taken Ex, you have taken Ey. So now RCP means put the thumb in wave propagation direction. Now it will be like this. So time, if you put the thumb in wave propagation direction, then a closed finger is in the time increase direction. It is like this. So now what is given actually? Is it clockwise or anti-clockwise, students? It is clockwise direction. Actually, this is not the way they ask the question, but ultimately we can't do anything. So that's why this is argumentative question also in GATE exam, but no problem. It is circular polarization. Clockwise we have to select. It is going clockwise. So it is clockwise. It is going. This is clockwise, right? Next, coming to this one. See the polarization of this one. Here, this has 1 e power j0. This has 2 e power j0. Both have same phase. That means both components have same phase, means both components have same phase. That means phase difference 0. So it is linear polarization. Linear polarization. Okay. Next, polarization loss factor. Already you know that polarization loss factor is already we have decibels required, no? Already we have discussed that formula. AI cap dot AA cap whole square. If you want decibels, then you have to take 10 log. First you take the vectors. Then antenna electric field is this one. Now unit vectors. So unit vector of incident electric field is AI cap. So AI cap, from this we have to take. So that is nothing but AX cap plus JAY cap divided by root of magnitude of this is 1 square. Modulus of this is again 1. You take 1 square. So that is ultimately AX cap plus JAY cap divided by root 2. And similarly, unit vector of antenna electric field is AA cap is equal to this one, that is AX cap plus 2AY cap divided by root of 1 square plus 2 square, that is equal to divided by root 5. Now AI dot AA you will find first, that is AX plus JAY divided by root 2 dot product AX plus 2AY divided by root 5. So ultimately AX dot AX is 1. So 1 by root 2, 1 by root 5. Next plus J into AY dot AY 1, 2 by root 2 root 5. You have to take modulus of this. If you take modulus of this, na, so AI dot AA modulus you take, then you get 1 by root 10 whole square 2 by root 10 whole square under root, that is the modulus of this one. Whole square you take, na, then root is gone. So ultimately you get 1 by 2 this one, 1 by 2. So this is actually polarization loss factor only, polarization loss factor this one. But if you want PLF in decibels, it is given. So PLF in decibel is required. So 10 log 10 PLF, that is half. So minus 3 dB you get. So this is the answer for that question. Here there was a confusion. This was argumentative question in GATE exam also. But you see, LCP also it is clockwise coming. For this also, if you put thumb into the, actually I was telling you, put right hand thumb in wave propagation direction, then this also clockwise is coming. So that is not the way to ask the question. He should have given simply RCP, LCP, no issue. That concept you know, so don't bother about that. Right. Next, question number 21, dear students. Question number 21. In this question, that fellow gave matching. Simply you have to substitute them in the what is that? So first I will tell you this question number 21. Matching is you have to do. So that fellow A, in option A, it is given d by lambda value 0.25 and alpha value 90 given. In B option, d by lambda is equal to 0.5, alpha value 0 is given. In option C, actually, d by lambda value 0.5, alpha value 180 is given. Alpha value 180 is given and d by lambda is equal to 1 is given in option D. So here in the matching, you see this x-axis, y-axis. That means here is measuring angle from x-axis. That is the meaning of that. It is given like this. Okay. Then in second one, x, y, angle is measured from x-axis. It is given like this. You should understand here also 0 is not there, that one. Some value is there, right? Then this is x-axis, y-axis, like this it is given, right? Next, fourth one is given like this. So this is x, this is y, and ultimately it is given like this, dear students. Okay. So for matching purpose, option D is matching. You know why? Let us substitute one by one. It is actually checking you have to do, student. Checking is to be done. First one, in you know that psi is equal to beta d cos theta plus alpha. He has given alpha and he has given what do you say d by lambda ratio. So psi is equal to 2 pi by lambda d cos theta plus alpha. Actually for electric field maximum value, I will do one thing. To get electric field maximum value, array factor should be maximum. So AF maximum occurs at psi is equal to 0. What is happening here, student? We will check maximum electric field angle we will find. Okay. So here he is taking, this is theta 0, this is 90 degrees, like this he is taking. This is 180 degrees, like this. Now I am trying to go solve psi 0 I will substitute. Then whatever theta angle I get, that is the maximum electric field angle. So for first option you see psi 0 is equal to 2 pi d by lambda cos theta plus alpha. This is general equation. In the first option it is given d by lambda is how much given, student? 2 pi. D by lambda is how much given? 0.25 is given. And cos theta plus alpha is given 90 degrees. So 90 means pi by 2 radian. So from this theta value I get 180 degrees, students. So here option D is matching. That means A matched with 2. You can see here. 180 degrees means this is 0, this is 90, this is 180 degrees, student. This is matching, you see. Some value is there here for electric field, but even though maximum is not there, okay, you have some doubt, sir, maximum is not there at 180, you may get doubt 180, but hold that one, don't worry. Because in other options, if you see, then you will come to know. In option B, it is given that this is the general equation I am writing, 2 pi d by lambda cos theta plus alpha. In second option, d by lambda is given as 0.5 and cos theta. Alpha is given as 0. From this theta value, if you find, student, if you find theta value, you get 90. So that means electric field maximum angle is this one. Here also this is electric field maximum angle, it should be. So electric field maximum angle is 90 degrees. So this electric field maximum angle is for third one, you can see 90 degrees. So this is the 90 degrees. Angle theta 0 here. I wrote here 90 degrees means this one for this. Theta is equal to 90. Angle is measured from here in this question. So actually here theta angle is nothing but horizontal angle, student. XY plane is given na. XY plane is given na. On the XY plane angle is pi actually. That fellow is taking that as a theta. So they do like that only in the questions. They are little bit problematic people. Okay. Next, for third case, that means for C case, 0 is equal to 2 pi d by lambda cos theta plus alpha is the general equation. And if you substitute d by lambda 0.5 for this, then cos theta alpha is given as 180, dear students. From this theta you will get 180 degrees, dear students. So that is for one matching, you see, for one it is maximum is there. So this is electric field maximum angle. Electric field maximum angle you got. So then option D you do checking. This is general equation to have a maximum array factor. Maximum array factor. Now you substitute the 2 pi, na? Yeah, 2 pi. So 2 pi into d by lambda is given for option D 1, and cos theta plus alpha is given 180 degrees. So ultimately from this alpha you get is 120 degrees. That is electric field maximum should be at 120 degrees. That is matching with equation 4. This is 0. This one is actually 90. Why na? Theta 90. This is actually 120 degrees. Right? So that means that is matching with fourth one. So option D, na? Option D is the correct for that. Option D. Actually, option D, what is given, student? ABCD, that means this ABCD, matching with 2, 3, 1, 4. Matching with 2, then 3, 1, 4. Actually, 3, 1, 4 are clearly visible for you, but you have doubt in 2, but you have to compromise, nothing to do. Even though here maximum is not there, but some value is there. So that is the way you have to solve this question. So dear students, this is question number 22 is this one, to avoid grating lobe. Already I have written, no? To avoid grating lobe, the condition is d less than lambda by 2 I wrote. So that is d less than 0.5 lambda. That is the answer. Right? Next, 23. So that fellow gave actually 23 question. Na? Here one diagram is given. Two identical antennas are placed in the theta is equal to pi by 2 plane as shown in figure. So like this 90 degrees plane, and he has kept one antenna. Dot means out of the board, in that current is going out of the board. Cross means into the board. So here current is going into the board. This distance he has given as a S. S means distance here. Confusing fellows. Actually, if you see yes, no, you will be confused. Oh, what is this yes? What is this yes? That is actually distance actually. D, no? Distance D. So, simply confusion done. Now, one antenna is there. It is antenna array question. In this current is out of the board. In this current is into the board. So, out of the board and into the board. Angle is 180 degrees. That's what he has given in the question. So, the elements have equal amplitude of excitation. That means I naught current, I naught current. Then 180 degrees polarity difference. Operating wavelength is lambda. That is true, no? If we, into this current I naught is into this and current I naught is out of the board, then 180 degrees phase difference is there. Okay. The correct value of the magnitude of the far zone resultant electric field strength normalized with that of a single element. Both computed for pi is equal to 0. Actually, he is doing pi measurement here, pi. So that means pi is equal to 0 here. Okay. Right. Now, the correct value of the magnitude of the far zone resultant electric field strength is. Actually, student, you know that total electric field is equal to E1 multiplied with array factor. Then normalized means here you take normalized array factor, this E1 is there, you have to divide. Ultimately, normalized electric field will be proportional to normalized array factor. So, dear students, En normalized electric field is proportional to what do you say, array factor only. Once again, normalized array factor, but you know that normalized array factor again is proportional to array factor only. And what I am telling is that this one. Now, array factor normalized value is equal to array factor divided by array factor maximum. Once again, array factor normalized is proportional to array factor only. So that is what I am telling students. So this is proportional to array factor. That means we have to find the array factor here. For this, I am starting the analysis. You can see. First, you find the array axis, student. Okay. You have to find the array axis. Okay, we'll do this. Array factor is equal to sin n psi by 2 divided by sin psi by 2, student. And for two antennas, two elements are there. For two elements, n is equal to 2, then array factor becomes a sin 2 psi by 2 divided by sin psi by 2. That is nothing but array factor is equal to 2 sin psi by 2 divided by cos psi by 2. That is sin psi by 2. After cancellation, array factor is equal to 2 cos psi by 2. You got sin cancel. Once again, array factor normalized is equal to here array factor divided by array factor maximum. So array factor is 2 cos psi by 2. This value is maximum whenever this is 0. So 2, that is and array factor normalized is equal to cos psi by 2 you get. So you have to find psi now. You have to find psi. No need to do this much, friend. Normalized electric field is asked means you find normalized array factor. It is very simple. For two element array, this normalized array factor is cos psi by 2. Previously you do not know, now you have done. So you have done, now you can array factor for two element array is 2 cos psi by 2. Normalized array factor is cos psi by 2. First time you are doing, from now onwards you will know, you need not to worry. पहली बार आप किया था ये, बाद में पता चल जाएगा. For two element case, array factor is 2 cos psi by 2. Normalized array factor is cos psi by 2. So psi you have to find. What is psi? Let us say this is equation number 1. Psi is equal to beta d cos theta plus alpha. So that is 2 pi by lambda into d cos theta plus alpha. Now you recall what he has given, wavelength is lambda. He has given wavelength is lambda. Answer is also in terms of lambda only. So you have to find cos of plus alpha. So okay. Now, okay, students. I will write if you want something also. Now let us start the analysis. Actually, D means what? Distance between antenna elements. So here you draw a line like this which connects these two antennas. Then this is called as array axis. Array axis means, what is the definition I wrote? The line on which antenna elements are there, that is called array axis. Next, now on the array axis, distance between antenna elements D is calculated. On the array axis means the line on which antenna elements are there. Now on the array axis, distance between antenna elements is calculated. Now it is Pythagoras theorem. This is 90 degrees. That is root of s square plus s square is root 2s. Now D becomes root 2s. Okay. Now alpha becomes 180. because this current out of the board, this is into the board, phase difference is 180 degrees, right students? Now this theta you have to find, student. Did you remember I wrote theta, theta, student? You recall the theta? Theta is okay. Theta is angle between array axis. This is the array axis, and line drawn from origin to the field point. Actually, he is saying the field is measured at pi is equal to 0. This is the field point. So this is the line drawn from origin to the field point. Then angle between the line drawn from origin to the field point and the array axis. This is the array axis, student. That is the angle actually. So that is once again I am writing here. I am writing here for that. So theta is angle between array axis and line drawn from origin to field point, or otherwise angle between a line drawn from origin to field point and the array axis. This is the origin. He himself said the electric field is measured at pi is equal to 0. So line drawn from origin to the electric field point, he said electric field is calculated at pi is equal to 0, he said. So this is that line, and the array axis is this one. So now this angle is theta. That is actually in this triangle, this is 90 degrees, then equal lengths are there. This is 45, so this is also 45. So then this angle becomes 180 minus 45. So that is actually 135. 135 means 90 plus 45. So that theta is here. Theta angle is here, students. 130, 90 plus 45, student. That means second quadrant. That's why I am writing like that. Now alpha is what, dear students? 180 degrees. 180 degrees. So that is equal to 2 pi by lambda root 2 s cos of 90 plus 45 is second quadrant. Now this is negative, minus sin 45. So that is minus 1 by root 2, you get plus 180 degrees, that is psi. So ultimately psi is equal to root 2 cancel, and 180 degrees minus 180 degrees minus cancel, this one root 2 minus I have kept. So 2 pi s by lambda. 2 pi s by lambda. Now psi by 2 is equal to 90 minus pi s by lambda. So here this is equation number 2. So psi by 2 we have calculated here. Put 2, equation 2 in 1, then array factor normalized is equal to cos of psi by 2 is 90 minus pi s by lambda. So cos of 90 minus means you get sin pi s by lambda. So sin pi s by lambda. Acha, 1 minute, student. Actually, we want array factor. 1 minute. What is required actually? The correct value of magnitude of the far zone resultant electric field strength normalized. Acha, student. Normalized with that of single element, student. I did not read the question properly. Total electric field normalized with that of single element. Actually, electric field, total electric field normalized with single element. That means this is array factor only. Then no need to do this mathematics. Simply you have to find array factor, student. So total electric field normalized with electric field of single element means E total by E1 is required. That is array factor is required. Now no need to. This is required actually. This is required. Anyway, keep it like this. Don't worry. But array factor is asked here. So array factor is asked, then 2. Because no, If you normalize total electric field with single element electric field, that becomes array factor. Then array factor for two element antenna is 2 cos psi by 2. So that is 2 you have to put here, 2 sine. You calculate this one. Okay, put it like this, don't worry. This is correct only. If you want array factor normalized cos psi by 2, you got this concept also here. Normalized array factor is required means cos psi by 2, but array factor is required means 2 cos psi by 2. So 2 you have to put here. So then that is in option D actually. So that's what I have seen. By seeing this 2 was missing, in all options 2 is there. So now what is asked is total electric field normalized with electric field of first antenna, that is E1. Normally divide with that, you get array factor. So array factor for two element is 2 cos psi by 2. But normalized array factor is again cos psi by 2 only. But asked is this one. So that is the answer, right? But what you have to do, while explaining this antenna array, I have written what is the meaning of theta and what is the meaning of array axis. You have to read them 1 or 2 times. Actually students, if you see any tough question, then you go to that concept. In that concept you see the meaning of every parameter. What is theta, what is alpha, what is d, everything is written. D means distance between one antenna element and the next antenna element. The distance is to be taken on the array axis we have put actually. So you read the meaning of the statements carefully, then you will be able to solve that question, right? Next next question is actually 24 question, dear students. So in this question number 24, what he is saying is a lambda by 2 is kept horizontally at a height of lambda by 2 above the conducting infinite grounded plane. The radiation pattern of the dipole looks approximately. So he is putting like this one, question number 24. So there is one conductor here. There is one conductor here, students. Now lambda by 2 antenna is there here. Lambda by 2 antenna, and it is at lambda by 2 height from this, and lambda by 2 antenna is there. So actually what happens, dear students, for this is also lambda by 2 antenna only. This is also lambda by 2. Actually similar to the Hertzian dipole is like this, then radiation pattern is like this. So here also situation is like this, the radiation pattern is actually like this, student, like this. Now whenever this conductor, you know that we have studied in the uniform plane wave, this is conductor, big conductor is there like this, big conductor is there. Near the conductor, reflection coefficient is 1. Whatever electric field comes here, that is reflected back with some 180 degrees phase. Then once if you reflect this, then here this one tries to nullify the electric fields here, so that that pattern looks like this, student. That pattern looks like this. So here it becomes like this, because if you see, this is the original field. I will draw like this. Okay, this is the original configuration of the, actually radiation pattern is 90 degrees to the length of the antenna. So that is why it is like this. That is for Hertzian dipole also like that only, for lambda by 2 antenna also like that only, for lambda by 4 also like that only. For rod, for antenna rod, always radiation is 90 degrees. Now here conductor is there, it reflects. While reflecting, 180 degrees phase comes. 180 degree phase means completely not reflected, unsymmetric reflection is there, because the distance is like that. So then little bit is reflected here, the reflected portion comes here, then that nullifies, then this portion remains. So the antenna pattern will be like this. It is actually standard question, student. So the answer is B for this. It is standard question. One time you analyze, na, at any time you see this question, you have to remember this as a standard question. So this is the answer for that one. So now question number 25. Question number 25. Actually, it is this question number 25. Actually, a broadside array of 4 isotropic point sources. Okay, a broadside array of 4 isotropic point sources. That means n is equal to 4 is given. Number of elements 4. Of same amplitude and phase placed along x-axis with a spacing of actually same amplitude is there and phase also same for all of them. Okay, placed along the x-axis with a spacing, distance between them is lambda by 2 between them. Adjacent elements has a polar pattern consisting of which of the following? Actually, that is the question. So that is the antenna. I am drawing diagram like this. So this is x axis. That x axis itself is array axis, student. Array axis. That means he has kept here the antenna elements like this. So like this he has kept. Okay. Here y axis is there. He is saying distance is d. That distance is equal to lambda by 2. Like that. Given alpha is equal to 0. That means same phase means student, they are at they have some phase. Every antenna, na, for example, this has some phase. Let us say theta phase. This also has same phase. This also has same phase. This also has same phase. I naught at an angle of theta. So that means what is alpha, student? Then alpha is phase of one current element minus phase of other one, so that is 0. Actually, I told you definition of alpha also. This fellow is saying all of them have same current magnitudes and same phases. You take some phase theta dash you can take, because theta meaning may be changed again. You will be thinking something else. Theta dash phase, same phase are there. What is the meaning of alpha? I wrote in the notebook, you see, phase of one current element, that is theta dash, minus phase of second current element, that is theta dash. So alpha becomes 0. Alpha becomes 0. Now electric field resultant pattern is decided by the array factor. So you write array factor, that is sin n psi by 2 divided by sin psi by 2, student. Okay, here let us calculate psi. Psi is equal to beta d cos theta plus alpha. Okay, now array factor is maximum whenever, okay, array factor is maximum whenever psi is equal to 0. What I am going to do, students, you keep listening, you will understand. This theta dash I kept. Current phase, no, he has not given no name of that. I have taken current phase name as theta dash. So theta dash minus theta dash is equal to 0. Alpha is 0. Now n is given how much? 4. Let it be like that. Okay. Array factor is maximum when psi is equal to 0. Now psi is equal to 0. What I will do, theta also, what is theta, dear students? That we have to find. Okay, psi 0, beta d cos theta plus alpha is 0, because alpha 0. You take this. Array factor is maximum and psi is equal to 0. You put psi 0, then beta d cos theta plus alpha. Alpha is also 0. From this we got cos theta is equal to 0. Can you tell me theta 0 when it will happen? Theta is equal to plus minus 90. Whenever cos of plus or minus 90 is equal to 0, that means array factor is maximum whenever theta is equal to plus or minus 90. If array factor is maximum means electric field value will be maximum. Okay. In the radiation pattern, whenever theta is equal to plus or minus 90, then you get array factor maximum value, then electric field also maximum value. Okay, array factor also maximum you get, electric field also maximum you get. In the radiation pattern, at theta is equal to plus or minus 90, you get electric field maximum as well as array factor maximum. Then how you calculate null, student? In the electric field pattern, how you calculate nulls? Nulls are calculated. Okay. N psi by 2 is equal to, null simply I will put, N psi by 2 is equal to plus minus k pi, where k is equal to 1, 2, 3, 4. That means in the field pattern, nulls are obtained whenever n psi by 2 is equal to plus or minus k pi. Every day k is equal to 1 and n value is equal to 4 is given. So alpha is equal to d by 2. Everything is given information. Now one by one let us calculate, student. One by one let us calculate. Here I have calculated for k is equal to 1, first case nulls calculation starting. That means what we are doing now, in the radiation pattern, maximum electric field comes whenever theta is equal to plus or minus 90. That point is over. Next, nulls come at which angles we have to calculate. So many options are there. First we will take for k is equal to 1. Then for k is equal to 1, n psi by 2 is equal to plus or minus pi, and n is equal to 4 it is given. N is equal to 4 it is given. Then psi value is n by 2 na, like that. Then psi value is beta. Beta is actually 2 pi by lambda. So I am using this one, student. N into psi by 2. What is psi? This one. So psi is equal to beta is 2 pi by lambda and d is given here. D is lambda by 2. D is lambda by 2. Then cos of theta plus alpha is given 0. If you have confusion, don't strike. Notebook में निकालो मत. और एक step लिखता हूँ मैं. N is actually 4 by 2. Psi is beta d. Beta is 2 pi by lambda d. Cos theta plus alpha is equal to plus or minus pi. Now you do 4 by 2, 2 pi by lambda. D is actually lambda by 2. It is given. And cos theta, we want actually theta value. Alpha is 0. Plus minus pi. Whenever you do this, I can do one thing, student. I will put this k only here, k. So that for all cases we get at a time. K pi we will do. We will take k pi. Then from this directly we get cos theta in terms of k we get. Because lambda lambda cancel. So you get k. This is 2 pi by lambda. Okay. So cos theta is equal to, let us see this one. This is 2 you get. This cancel. 2 cancel. Lambda lambda cancel. This is 2 pi cos theta is equal to plus or minus k pi. Now pi cancel. So cos theta is equal to plus minus k by 2 you get. Am I right? Pi cancel. Cos theta is equal to plus or minus k by 2 you get. Now where k value is 1, 2, 3, 4 like this. So whenever k value 1, 2, 3, 4, you get some angles. At all those angles, nulls are there. Now for k is equal to 1, cos theta is equal to plus minus 1 by 2. That means for this angle, no students, you get cos theta is equal to plus half, implies the angle is plus or minus 60, and cos theta is equal to minus half, then this angle is plus or minus 120, because cos is negative in second quadrant. Cos 60 is half, and minus half means that is cos 120 degrees. Then you can take k is equal to 2 here. When k is equal to 2, then here cos theta is equal to plus minus 2 by 2. That means cos theta is equal to plus minus 1. Cos theta is equal to plus 1 implies what angle you get? Theta is equal to 0. When cos theta is equal to minus 1 implies theta is equal to plus minus 180 degrees, then you get minus 1. Then no need to take 3. If you take k is equal to 3 no here, then 3 by 2 is 1.5. Cos theta can never become greater than 1. So you stop here. Now I am writing conclusion from above calculations. Electric field maximum occurs whenever array factor is maximum. Once again I am clearly telling, electric field maximum occurs whenever array factor is maximum. Array factor maximum occurs psi 0. After taking psi 0, we got theta value plus minus 90. So electric field maximum occurs at theta is equal to plus minus 90 in the radiation pattern that is fixed. Now electric field minimum, or the nulls, no, not minimum. Electric field nulls occurs at theta is equal to, you keep writing sequence 0, plus or minus 60, plus or minus 120, and plus or minus 180. These many angles. Now if you see here carefully, and this is x-axis, here theta is 0 here, and this is y-axis, theta is 90 here, and because no student, here xy plane that fellow gave, that is these antenna elements are on the x-axis. So antenna array axis is x-axis. From antenna array axis, this theta is measured. Did you remember? In the already I told you, theta is measured from antenna array axis. Actually, in the notebook, no, I have taken z-axis as array axis. I told you already theta is angle measured from the array axis. So theta 0 here, theta 90 here, and you can say 60, theta 60, from here it is 60. Okay, 90. Then this is theta is equal to 120, no? 30 degrees, little bit it has to tilt. Okay, no problem. Theta is equal to 120 is like this, students. Like this. Theta is equal to 120 degrees. Now theta 0, 60 degrees. 90 is for maximum. 120. Then this is theta is equal to 180 degrees. Measured from here like this. What I will do, you see. Theta 60, theta 120. That means here to here, you can understand, maintain the same, it is 30 degrees. Then this is also 30 degrees, you can see. Theta is equal to 60, it is, but from 90 you come this side, this is 30, that is also 30. So now what is happening, student? Like this you get radiation pattern, you see. At 0, what should be there? Null. I will tell you. Like this you draw. Like this also it can go, no problem. Like this you have to draw. Then like this you draw. like this you draw. Now highest value should be here. Theta is equal to plus 90, minus 90 means bottom side. So here you can see highest value. Now it is concluded, you see. E maximum occurs at theta plus or minus 90. This is 90 degrees electric field maximum. Here also maximum is there. I will decrease the size of them so that you get the feeling. Here you see minor lobes are there, minor lobes. How I came to know here minor lobes are there, you know? Very simple, student. At theta 0, I have to get null. Yes, this is null actually. There should not be any radiation. That means when radiation is there, but when you come to 0 angle, radiation should become 0. And similarly, from this direction, you come to null, you come to 0 degrees, there should not be any radiation. You can see whenever you come to 60, then also null should be there. But beyond that, radiation is present. When you come to 120, then also null should be there, null, 0. Then when you come to 180, 120 also null is there, and 180 also null is there. You see only top side. At theta 0, null should come. At theta is equal to 60, null should come. Null means 0. At theta is equal to 120, null should come. That means it is coming here. At theta is equal to 180, null should come. Then this side no need to see, that is symmetric pattern. So this is the answer, and it is a little complicated question for you. But anyway, sometimes in exam these type of questions also they ask. So what is the answer actually? C option is matching with this. Option C is matching. Option C is matching here. Okay. Now that question number 26. Okay. Question number 26 you have to solve. So dear students, this is actually question number 26. Okay. Given antenna array has a number of elements, 4 students. Okay. Spacing between the elements, it is given spacing between elements d is equal to lambda by 4 is given. Okay. Now array factor, alpha value is not given, no? So we have to take alpha 0, student. Now array factor is equal to, we know that sin n psi by 2 divided by sin psi by 2. Okay, where psi is equal to beta d cos theta plus alpha, right? Actually, dear students, first let us calculate psi. Alpha is not given in the question, so take alpha 0 if not given means. Then psi is equal to beta is 2 pi by lambda d cos of theta, of course, plus alpha. Now let us calculate this 2 pi by lambda, d is given as lambda by 4, and it is cos theta you take as it is, alpha not given means 0 you take. So lambda gone, you get pi by 2 cos theta, right now? So pi lambda gone, 2 gone, pi by 2 cos theta you get. Now substitute in array factor. In array factor, if you substitute, then sin n is n value is 4 given, no? So 4, psi is pi by 2, then psi by 2 is there means you get okay, you put, no, this psi is actually pi by 2 cos theta, psi by 2 means pi by 4 cos theta. So divided by downside, what is there? Sin psi by 2 means pi by 4 cos theta. So you have to cancel them, na? That is why what to do, first you 2 into 2, 2 into 2. Then you get, actually what I am doing, student, I am writing 4 as a 2 into 2. So this is all sine 2 theta expansion, 2 sine theta. Now theta is pi by 4 cos theta, 2 sine theta, and cos theta 2 pi by 4 cos theta divided by sine pi by 4 cos theta. Once again you expand this one. So ultimately array factor is equal to, if you expand that one, again 2 into 2, you expand this one sine, then sine pi by 4 cos theta cos pi by 4 cos theta divided into cos 2 into pi by 4 cos theta divided by sine pi by 4 cos theta. This cancel. So array factor is equal to 4, you get this cancel, then cos of pi by 4 cos theta, then cos of pi by 2 cos theta you get. So 4 cos pi by 4 cos theta, cos pi by 2 cos theta. It is in option A, student. Option A. Now next one, for Hessian dipole. For Hessian dipole, directivity, already I told you to remember this one. Directivity is 1.5. It is standard question. Now next question, for lambda by 2 dipole, dear students, it is for lambda by 2 dipole, I told you to remember, for lambda by 2 dipole antenna, D is equal to 1.64. Then for lambda by 4 monopole near ground, for lambda by 4, these are standard questions, monopole near ground, double of this one it becomes, because that is reflected. It is different concept. You don't worry about that. You remember them. It is double of this 3.28. These are all standard questions, these three. Next question, it is given like this, dear students. If you see this, this one is, let us take this as a, he has given the axis, so x axis and y axis and z axis. Now here two antenna elements are there on the x axis, means so this is array axis. What is the definition of array axis, student? The line on which antenna elements are there. So he has given distance between them is d, and he is saying he is measuring the electric field at point P. Okay, then angle between array axis and the line drawn from origin to electric field point, electric field is measured here. That angle is 60 degrees is given. That is nothing but theta only, student. Now two half wave dipole antennas placed as shown in the figure are excited with sinusoidally varying currents of frequency. So frequency is 3 megahertz is given, and phase shift of pi by 2 between them. Phase shift of pi by 2 between them. That means phase shift of pi by 2 means alpha is pi by 2, right? Next, the element at the origin leads in phase. Leads in phase. That means actually what you have to do, student, here he has done nicely, that he is saying the phase of this is what do you say, leads means pi by 2, this is 0 phase. But I told you alpha means in the sequence second element phase minus first element phase. I told you, student. Alpha, I told you, you remember, alpha is nothing but second element phase minus second element current phase minus first element current phase. Have you seen? I was telling you like this: first antenna, you increase the distance, then this is second antenna element phase this one, first antenna element this one. So origin antenna, actually second antenna phase alpha minus origin antenna phase is 0. Alpha minus 0 is alpha. That is the meaning of alpha. Here second antenna phase is 0 minus first antenna phase is pi by 2. So first element current phase here. So second antenna, it is 0 minus of pi by 2. So ultimately minus pi by 2, that is alpha. Then what else? Calculation. Lambda frequency is given, na? Lambda is equal to C by F. So 3 into 10 to the power 8 divided by F is this one. You get 100, student. 100. Next, so you have to find D here. You have to find D. So find D. That is the question. So find D. Now psi is equal to beta D cos theta plus alpha. Actually, this fellow is saying maximum radiation is required. Maximum radiation is required here. Electric field maximum. For electric field maximum, psi is 0. So psi 0, 2 pi by lambda. Of course, lambda we found into D cos theta plus alpha. Can you tell me what is theta? Theta is angle between array axis and line drawn from origin to the electric field point. This is theta is given. Okay. So 0, 2 pi by lambda is 100. D is required cos 60 this one. So from this you can find 2 pi by 100 into D into cos 60 is what, student? That is half, na? Is equal to minus pi by 2. Pi cancel. Here 2 cancel. Pi cancel. 2 cancel. D by 100 is equal, minus is not there, na? D by 100 is equal to 1 by 2. So D is equal to 100 by 2. That means D means 50. 50 meters it should be. So he is saying, in the question also you can read, if the maximum radiated electric field is at point P, this is maximum electric field radiated point P in the xy plane, occurs at azimuthal angle of 60, the distance D is. So distance between array axis and line drawn from origin to the field point, field is measured here, that is theta, theta is 60. Then electric field maximum is there. For that, array factor should be maximum. So for array factor maximum, so for electric field maximum, array factor should be maximum. For array factor maximum occurs at psi 0, right? So this is the answer. So my dear students, actually I want to suggest you only one thing: read the easy subjects less number of times, read the tough subjects more number of times. So that should be the strategy, and work hard and have a nice time. All the best, and God bless you. Thank you very much. So actually, students, for GATE students, static electric field and static magnetic field chapter is not there. So after covering the coordinate system and curl, divergence, gradient, Laplacian operator formulas, directly you have to go to the Maxwell equations, time varying fields and Maxwell equations. But what I am doing, in between, I am giving some lectures in static electric field and static magnetic field, so that you will learn some basics of static electric field and static magnetic field, so that smoothly you can go to the time varying magnetic fields. Because suddenly, without discussing static electric field and static magnetic field, suddenly going into the time varying fields, uh, then you will be little bit uncomfortable. So that is why no need to cover entire static electric field and static magnetic field. Only few lectures are given in static electric field and static magnetic field, so that you can smoothly go to the time varying electric field and time varying electric field and Maxwell equation. So in that way you need not to worry that हम लोगों को भी स्टैटिक इलेक्ट्रिक फील्ड स्टैटिक मैग्नेटिक फील्ड पढ़ा रहा है, ऐसा फील मत हो जाओ, क्योंकि थोड़ा सा पढ़ेंगे इधर उधर आपको फील आ जाएगा, सडनली जंप ना हो इससे उधर, बट लेकिन आपको गेट सिलेबस में इस बार तो निकाल दिया वो, इसलिए थोड़ा स्मूथली ट्रांसफर होने के लिए थोड़ा सा पढ़ाया उसको, राइट स्टूडेंट्स? ओके, so students, in the workbook I am writing the questions. You don't bother about the question numbers. You see the question and you think of the solution. So you don't search for the question. Okay, the question numbers may be changed, so that's why you don't bother about them. After concept, I am teaching you the questions associated with the concept, so you will not have any problem.